casing should be prepared in advance. Centralizers, for the best results, should be placed approximately 8 feet from the pin end of the casing. This placement helps to support the heavier coupling section of the pipe and helps eliminate sag. During the makeup of pipe, couplings are used at each joint to connect the casing together. The couplings make the pipe rigid and can cause problems when running casing in an open hole, such as channeling or key seats. This should be avoided wherever possible. In open hole, the walls of the wellbore are sharp, rigid, and often fragile. The casing is heavy, solid, and doesn't easily curve with a hole. The well rugosity or wellbore roughness is often ignored but should always be taken into consideration. Often it is presumed a horizontal well looks like this: horizontal, straight, smooth. In reality, when the wellbore is being drilled, the bit turns, torques, and literally hammers away, creating the hole. This causes more of a corkscrew effect. The wellbore is neither straight nor smooth. When the casing is inserted into the open hole, the casing must conform to the curvature of the rough and rigid walls of the wellbore. Gravity pulls at the heavy casing as it tries to drag on the bottom. Most often, the swing and inclination is as high as 4 degrees. Now, bridging and other aspects apply to getting the string to the bottom. The most important part of getting the string to bottom and getting a proper cementing job is standoff. Standoff is the space between the casing and wall of the wellbore. It is measured in percentage ratios, which determines how centered the casing is in the hole. It is natural for the standoff to vary in different areas of the wellbore, but if it drops below 67% in any area of the wellbore, the results could be devastating. Looking at the tight spot, we can tell that the casing on the left is literally up against the wall of the annulus. This could cause loss of production and expensive remedial work due to migration and possibly make the well unstable. On the right, you can see that proper centralization will maintain a good standoff. When running the casing downhole, the lack of centralization will increase drag significantly. Pipe and couplings will drag the entire length of the well, which may result in additional push requirements. Key seats, the common grooves created by the couplings of the casing joints, cause gouging, lost circulation, or even stuck pipe. All of which can be simply avoided by having the best standoff due to proper centralization. Washouts are extremely common in many wells, requiring vast amounts of excess cement. But little to no consideration of the correct centralizer type is discussed. Correct centralization is the cheapest yet most reliable way to get the string to bottom and achieve a good cement sheath. A bad cement job can have devastating consequences. Imagine having a cement job with no centralizers. The casing is on the wellbore wall. The cement is very fluid and will simply take the easiest route or path. It will not get under the casing. Rotation alone will not keep the casing centered in the wellbore. The pipe will not be suspended in the wall. We cannot assume that the casing will be perfectly suspended 3 miles downhole. The cement is meant to stabilize the wellbore and prevent gas migration and corrosion. After fracturing, a poor cementing job could cause loss of production, contamination, and early workovers. This will reduce production and increase the costs. Centralizers will enhance the well life, not subtract from it. The key issue is, what is valuable to you? Spend now and reap the rewards for years to come. Reduce the overall well costs, including production. Or save a little now and pay a lot later.